Hello everybody. Today we're going to talk about ratios and rates. So before we get into some mathematical examples, first I want to give a definition of each one. So a ratio is a comparison of two things that are of the same or similar units using division. So we are dividing in a ratio. So ratios can be expressed a couple different ways. So the first way is we could have the word 2 in front of it. So we could say 3 to 4. That would be one example of the way a ratio is expressed. It could also be expressed using a colon. So we could have 3:4. And then the most common mathematical way would be a fraction. So it would be 3/4. So those are the three different ways you could see a ratio expressed. And you could easily convert between the two forms. So for example, if you have the word 2 in your ratio, well, the first number would go in your numerator. The second number would go in your denominator. Okay? Now, primarily in algebra, we're going to use the fractional form of a ratio. Okay? But again, you might see those other forms. And just so you're aware, that's what those other forms look like. So let's say we're asked to express the ratio in lowest terms. So we have 16 students to 30 students. So let's say we're talking about comparing two classes, and one class has 16 students, the other class has 30 students. So what would the ratio be of the first class for the total number of students compared to the second class and their total number of students? Well, we want to put this in a fractional form, so the first number is going to go in the numerator, and the second number that comes afterward, 2, is going to go in our denominator. So we have 16 over 30. But just like anytime we're working with fractions, we want to simplify. So if we look at simplifying that fraction, 2 is the biggest number that divides into the numerator and denominator. So if we divide those both by 2, we get 8 over 15. So that would be this ratio in simplest form, 8 over 15. Now, it's really important, though, the order. So if it says 16 to 30, you have to make sure you put 16 in the numerator, because you could also switch that ratio and it would be a different ratio because you're comparing it in a different form. So, for example, if we did 30 students to 16 students, well, the word 2 separates your numerator from your denominator. Let me clean it up a little bit. But the word 2 separates your numerator from your denominator. So this ratio here would be 30 over 16. But now when we simplify, 2 would be the biggest number that goes into both the numerator and denominator. So we'd get 15 over 8 for this ratio. Okay? So it is important, just like we talk about dividing numbers and things like that. The order in which your ratio appears is very important. You keep that order consistent. So the first number before the word 2 would go in your numerator. The second number after word 2 would go in your denominator. So let's say we want to express this ratio in simplest form. So we have 24 apples to 40 oranges. Now you might say, well, Mr. Pippage, these aren't the same. That's right. A ratio compares things of the same or similar units, right? These are very similar because they're both types of fruit. Okay? So we would do 24 over 40. And then we look to simplify. And the biggest number that goes into both of those is actually 8, right? So 24 divided by 8 is 3. 40 divided by 8 is 5. So the ratio of apples to oranges is 3 to 5. So that means for this ratio, for every 3 apples, we have 5 oranges. Okay, so here we have another ratio, expressed a ratio in simplest form. We have 4 weeks to 10 days. Now remember, these are very similar because they're both units of time. So a lot of people would look at that ratio and probably right away do 4 over 10 and then write 2 over 5. Unfortunately, that would be incorrect, because what happens is when you're doing a ratio, if you could make your units be the same, you want to do that to get the proper ratio. So we can actually make weeks into days. We could also make days into weeks, but that's going to be a decimal, because if you look, there is 7, and you have to know there's 7 days in a week. This is a little bit of what's called a unit conversion. Let me rewrite that because it's actually improper. So in 1 week, there is 7 days, right? So we're using a little bit of what's called a unit conversion. We got to know that fact. and we'll get into more about unit conversions in the next section. But since 1 week has 7 days, if there's 4 weeks, that means we have 28 days. Okay? Now, we could have also converted the days to weeks, and we actually would have got, believe it or not, the same exact ratio, but that's going to be a decimal or a fraction because there are 7 days in 1 week, right? So that's going to be about, 1 point something weeks, okay? So it's easier to convert the 4 weeks to days. So now we can do 28 over 10 as our ratio because now we have 28 days to 10 days. And if we simplify that, the biggest number that goes in the numerator and denominator is 2. So we get 14 over 5. So that's our ratio in simplest form. Okay? Let's look at another one like that. So let's say we have 50 cents, and I'll use the symbol for that. So 50 cents to $8. So that is a ratio. And again, you don't want to do 50 over 8 there because even though they're both forms of money, we can make them be the same. And I'll actually do this problem 2 different ways. We could have did the last problem like that as well. But we either have to convert these both to cents or both to dollars. So you do have to know that in $1, and this is again a little bit of a unit conversion, in $1 US, there is 100 cents. Okay? So in $8, that would be 800 cents, right? So now we made these be the same. Now we can do our ratio, 50 over 800. And if we simplify, we would get 5 over 80. Actually, that could be simplified more, right? Those could both be divided by 5, and we would get 1 over 16. So that is our final ratio in simplest form. So now the way I did it is I converted both of these to cents. We could actually do it a slightly different way. So check this out. There's our final ratio, right? 1 over 16. Well, let's convert them both to dollars. So let's do it that way. So we'll leave 8 is $8. 50 cents is 1/2 of a dollar, correct? Or $0.5. Okay? So now we can do our ratio, right? It would be 0.5 over 8. Now, we really don't usually like to have a decimal in our fraction. So if we want to make that a whole number, we would just times the numerator and denominator by 2. We're allowed to do that as long as we're, just like we reduce by the same number. We could also multiply the numerator and denominator by the same number, and we get 1 over 16. But notice we got the same exact ratio as before. So basically with a ratio, guys, if you can make the units be the same, you need to do that to get the proper ratio. Okay? So a ratio compares things to the same or similar units. If you can make your units be the same, you want to do that first, and then make your ratio and simplify. So a rate is a comparison of things of different units using division. So it's a very similar definition to a ratio, but with a rate we compare things of different units. And rates are usually speeds, okay? So usually it's going to be a distance divided by a time or something measurable. So it might be something like feet per second, or the most common with cars is miles per hour, which we could also write as mph. Okay, so usually speeds are rates. Okay, so here we have a problem. We have 335 miles in 5 hours. So the directions might ask you first determine whether it's a ratio or a rate. Well, in this case, this is going to be a rate. Now, of course, we just gave you the definition for a rate, but how do we know it's a rate? Well, we have a distance, miles, divided by a time, right? So that time could be hours, minutes, seconds, okay? Any type of unit of time you could think of, even maybe weeks, months, whatever it may be. So it's usually a distance or something measurable divided by a time. So we have, and actually when I go back to the other slide, I want to put that something measurable right there with the distance versus the time. So it's a distance or something measurable divided by a time. So let's say we have 335 miles in 5 hours. We could actually figure out how fast this person is going or this speed per hour. So let's divide 335 miles by 5 hours. So you might use your calculator for that. But when you divide 335 by 5, it looks like it goes in there 6 times. You should get 67 as your answer. Now, with a rate, you keep your units. So we were dividing miles per hours. So therefore, this is 67 miles per hour. Okay? So if a person travels 335 miles in 5 hours, they were going an average speed of 67 miles per hour. Okay? And this is also what's called a unit rate. A unit rate is where your rate has 1 in the denominator. And since 5 went into 335 to be an integer, 67, this is a unit rate. So a unit rate is out of 1. So if your denominator is hours, then it'd be out of 1 hour. So a unit rate is when your denominator for your unit of time works out to be 1. And with a rate, you always want to keep your units because it's something measurable. With a ratio, there's no need to keep your units because it's actually just a comparison of the relative size of the things you're comparing. And actually, depending upon which way you do your ratio, it's going to work out the same way mathematically, even though you might have different units. So ratios, you do not need to keep your units, but rates, you need to keep your units in the final answer. Okay, so to finish off, I want you to try these problems on your own. So for both these problems, you're first going to determine whether it's a ratio or rate. So you're going to write one of those words. And then simplify your ratio or rate in lowest terms and make sure you keep your units if it's a rate. So go ahead and pause the video and try these on your own. So the next 15 seconds will be blank. Okay, so hopefully you tried these on your own. So the first one is actually a rate because it's something measurable, which is words, divided by a time. So we're going to set it up, 470 over 4. We'll keep the words in the numerator and minutes in the denominator. Just write the word rate there. Clean this up a little bit. There we go. Sorry about that. So now we just got to simplify. Well, 4 does actually not divide into 440 to be an integer. So we want to simplify this in lowest terms. So 2 does go into both of these. Okay. So 470 divided by 2 is going to be 235. And then 4 divided by 2 is going to be 2. So this ratio simplified in lowest terms would be 235 words in 2 minutes. Now, if you want to get a unit rate, it just wouldn't work out to be an integer in the numerator. So you could divide 235 by 2 or 470 by 4, and that would tell you, and you probably assume this is a person, how many words they could read per minute. So if we divide 235 by 2, you'd get 117.5. So they could read about 117, 118 words per minute. Okay? But that's our ratio simplified in lowest terms. Or rate, excuse me. Simplified in lowest terms. Now the second one is actually a ratio, like I mistakenly just said just now, because we're comparing different types of automobiles. Okay? Now we can't make trucks into cars, so we're not going to convert like we did some of the earlier problems where we converted cents to dollars, or we converted days to weeks or weeks to days. We can't do that. You can't make a car, relatively speaking, into a truck, at least not very quickly. So we just set up our ratio, which would be 145 over 55. Remember that 145 has to go in the numerator. Sometimes it might be helpful to circle that word 2 or put a box around it. And now we simplify. So 5 is the biggest number that goes into both of these. So 145 divided by 5, let's see, it goes in about 2 times. 29 if we divide it by 5. And then 55 divided by 5 is 11, okay? So maybe we're talking about like a parking lot, and maybe for every 29 trucks, there's 11 cars. So that would be your ratio in simplest form. So thank you very much for your attention. Hopefully you found this video lesson helpful about ratios and rates. If you have any questions, please let me know. Thank you very much and have a fantastic day, everybody.